Hi, this is Walter. I'm here to do a solution video for homework 3. So here's our diagram of the Earth that you should be familiar with. First question asks you to think about a person in Argentina. So Argentina is a pretty big country. Argentina spans a wide range of latitudes in the southern hemisphere. We don't really care where in Argentina you choose to draw your person. But for our purposes, we will pick our person to be perhaps at this latitude right here. So that's where they are. So the first thing I ask you to do is draw what they do over one day and figure out how many hours of sunlight they get in one day. So the path they make is a path of constant latitude. So draw this here. So they go like this in one day. This orange dotted line that I'm drawing in. And I ask, how many hours of sunlight would they have in June? How many hours of sunlight would they have in December? So this blue dotted line here divides the night side and the day side of Earth. Now, in December, this side is daytime and this side is nighttime. In June, this side is daytime and that side is nighttime. So we're kind of cheating. We're doing both halves of the year in one diagram. So let's label this. So this way is day in December, at night in June. This side of Earth is the day half in June, but the night half in December. So if we look at our person's path, right, they have a lot more time on the day in December and night in June half, but a lot less time over here. What color shall I use? I'll use purple. So for our person, this is question 1 from your homework again, in June, they would have only a little bit of light and a lot of darkness. So if I kind of look at these and eyeball it, this is maybe 2 or 3 to 1. So you could say, well, in June, they might have 7 or 8 hours of light, whereas in December, they would have 16 or 17 hours of light. We're not doing exact calculations here, but they'd have a lot more sunlight in December. So December is their summer solstice, and June is their winter solstice. Question 2 asks you to draw stick figures of where they are at noon. So noon is where they are on the day side. So let's draw those stick figures. Now a trick is to draw the torso of the stick figure first. And then fill in the rest of the stick figure later to make sure their head goes in the sky. Mess that up a little bit. I'm not an artist. So then our person over here, here's their torso, here's their body, and there's their head. So now I'm asking where they would look to see the sun in June and in December. So what we need to do is figure out some landmarks for them. So if I'm thinking about my person, so here's their horizon line. Right? The horizon separates the stuff below their feet from the stuff above their head. So here's the horizon for this stick figure in December. That way is north, that way is south. And this is up, straight over their head. So that points to this observer's zenith. Remember, things like north and south, high in the sky, low in the sky, zenith, nadir, all of these direction words are specific to the observer. So someone in Syracuse, someone on the equator would have different up and down and north and south horizons. So to finish this, where is the sun? Well, the sun points that way. So if I look at this, our person standing here in December, right, so this is a person at noon in December, they would see the sun quite high in their northern sky. It's much closer to their zenith than to their northern horizon. So noon in December, sun high in northern sky. Now let's draw the same thing for our person in June. So for them, that's their northern horizon. That's their southern horizon. That's straight overhead for them, and a line going to the sun would be here. So this goes to the sun. So here, you'll notice that the sun is a lot closer to their northern horizon than it is to straight overhead. So here, in June, in the middle of their winter, let's label that, noon in June, they would see the sun low on their northern horizon. And this makes sense, right? The sun is much higher in your sky, much closer to overhead in the summer, and much lower in the sky, closer to your horizon in the winter, right? June is the winter for someone in Argentina. Okay, so we figured out Argentina. The next question, I ask you to figure out where on Earth you would need to be to see the sun directly overhead on the June solstice. So we're going to bid farewell to our stick figure in Argentina, and we need a new stick figure. So this is what that person does. We've reflected them over the year, right? Here's noon in the summer, here's noon in the winter. Now we need a new stick figure. And if I'm going to see the sun directly overhead in June, well, I need a stick figure that's directly facing that way. And you'd say, well, this is going to be, well, on this line, right on the horizontal. So here's my stick figure. Doop. So if I think about that person's horizon and directions, right? North, south, and up. So what's directly over their head? Well, the sun. And this is why the tropics are special, right? The Tropic of Cancer is the place where the sun is directly over your head on the June solstice. The Tropic of Capricorn is where the sun would be directly over your head on the December solstice. Someone just asked me, a colleague asked me a few minutes ago, why are they called the Tropics of Cancer and Capricorn? Well, thousands of years ago, the sun was in Capricorn on the June solstice. Excuse me, the sun was in Cancer on the June solstice. So we called it the Tropic of Cancer because when the sun is in Cancer, it's directly overhead. And likewise, when the sun is in Capricorn in December, the sun is directly over your head if you're standing on the Tropic of Capricorn. Now, we know that the alignment between the zodiac signs and the changing seasons shifts over thousands of years. We can talk about why that is in class a little later. But these were the names given thousands of years ago when that was the alignment between the zodiac signs and the seasons. So this is why the tropics are special, and there's our stick figure. The next question I ask is, where would you have to be to never see the sun on the December solstice? Okay, so we're thinking about this side. And if I'm never going to be to see the sun, I need to spend all of my life on this side of the Earth, right? So if I'm never seeing the December sun, my entire path over the day has to be on this side. right? I'm looking for always that. Well, that's what is special about the Arctic Circle. Right? If I am here, right, the Arctic Circle is kind of already drawn in, but if I am here, or if I'm above it, right, anywhere up here, I will never see the sunrise on the December solstice. So, you could say the North Pole, right? They'd never see the sun, but anywhere north of the Arctic Circle. Likewise, anyone south of the Antarctic Circle would never see the sun in June. The last question on your homework says, someone says that the sun is high in their northern sky in June and high in their southern sky in December. So we need a person who would see the sun in their northern sky during part of the year, in June, and would see the sun in the southern sky in December. So I've drawn a lot of stick figures and stuff. I'm going to erase them just so we can add new ones. While I'm doing that, I'd like you all to think about this. So this stick figure will go away. This stick figure will go away. I'm going to add one more. Actually, as I do that, I'm going to check my camera. Okay, we're good. Now, you may have already figured out what's happening. I need to be, if I'm like below this halfway point, right, if I'm down here somewhere, I would have to look north to see the sun. But if I'm up here somewhere, I have to look south to see the sun. And you might have concluded, well, anywhere between the tropics will do. Because this is the place where the sun's overhead in June, this is the place where the sun's overhead in December, and anywhere between the tropics of Capricorn and Cancer, I'd see the sun alternating between the northern and southern sky. As an example, let's pick a person on the equator. So if I have a person standing on the equator, right, so here they are. Here they are in December. And I draw my little guideposts, north, south, up, and that way goes to the sun. And then likewise, for their observing position in December, north, south, up, the sun. Well, the sun is in their southern sky pretty high in December, and the sun is in their northern sky pretty high in June. So people on the equator have a very different experience with the seasons than we do in Syracuse. So that's the solution to homework 3. I'd like to talk for a minute about what will be on tomorrow's quiz. So I tell you that I'm going to ask you 2 questions. One of them I'm going to tell you where somebody is on Earth and ask you how much sunlight do you get and where do you see the sun. For that, all you do is draw these stick figures. Right? So when I ask you that on the quiz, suppose I ask you something about Syracuse. Well, we know Syracuse is between the Tropic of Cancer and the Arctic Circle. So you would draw a stick figure up here, and you'd say, okay, here's Syracuse. I have to go get my orange chalk because, of course, we are Syracuse orange or something. I draw a stick figure in Syracuse. I'd say, there's my path, and figure everything out from there, just like we did for Argentina. In the second question on tomorrow's quiz, it'll go backwards, right? I'll tell you something about hours of sunlight, something about where you'd see the sun, and ask you when that would happen. And there you just have to use your deductive reasoning backwards, and you can use a diagram like this to check and make sure what you're thinking is logical. So, thanks for watching. I'm going to go post this on YouTube and then check on the people in my office hours. Thank you all very much.